Hello, my name is Daniel Cook, and this is my final project presentation. Team name is Team Name 1, and the project members is just me. So, my project idea was to make a matrix determinant calculator, and I would first I would make a CPU implementation where it would sequentially calculate it. It's decent, but when it ends up being large matrices, it's going to take a very long time to calculate. And then I was going to try and linearize it on the GPU and see if I can make it faster. And then I was just going to do some time trials with different matrix sizes and see how the two implementations stack up. Um, so how did the GPU get used? So I wasn't able to implement the GPU to work. Uh, I did a few attempts. So the first attempt, I tried to make it to where the top line of the matrix, I would calculate those determinants using a GPU and then just add them together. For example, if I ran like an 8 by 8 matrix, I would take 8 threads of the top values and then I would determine the values of the 7 by 7 matrices on the GPU and then finally return the values and add them together. I really couldn't get it to work, and then I tried to run it using the naive implementation, and then it would go down and recurse down, and eventually it would get to the 3 by 3 matrices, and it would pass those matrices to the GPU to calculate them and then return the values. I honestly couldn't get that way to work either. Uh, basically, I've spent like the last half a week trying to get this to work on the GPU and have got very little results out of it and just wasted a lot of time. Um, so implementation details. Basically, I was able to implement it on the naive CPU calculator, but I wasn't able to implement it on the GPU. And then I wasn't able to get the results for the GPU for obvious reasons because it doesn't work. Um, so how does the program run? So you're going to pass in three values. The first one is going to be an int. If it's a 0, it's going to run on the CPU. If it's a value other than 0, it's going to run on the GPU. The second value is another int. This is the size of the matrix that you want to calculate the determinant for. So like for a 4 by 4 matrix, you would just pass in a 4. And then the final value is a name of the matrix, like .txt file, which is just a text file that stores the matrix. So if you, like an example of running it on Blender would be the basic mvprof, and then the determinant calculator is the name of the program, and then you pass it a 0 and a 5, and then matrix 5.txt. Basically, you'd be telling it to run on the CPU. It's a 5 by 5 matrix, and here's the file name. Here's some results, but we'll come back to that after looking at some code, I guess. Um, so it's on Blender, and so we'll just check out final project. First, we're going to check out what the matrix looks like, just so that you know what the input is going to be. Basically, it's integers with a space between them. They can be negative, it doesn't really matter. They don't actually have to be stacked like this. It's just easier for you to read, but you can just have them all on one line, or you can have them all going down if that's what you want to do. So let's actually look at the code. So we're going to check out the main. So it includes, here's the function. This is the naive implementation. It takes in an int n, which is going to be arg2. So that tells it how big a matrix. Makes an array of n times n size. Reads the file to get the inputs and puts them into the array. Then it takes the array, puts it into a matrix of 50 by 50, just so that it's large enough it's not going to be an issue. It also outputs what values are in the matrix so that you can actually see what you're calculating. And then finally, that was all the setup. If it was if arg1 was a 0, you're going to run the naive implementation, which is just reads the clock time, outputs the determinant, and then runs the function and outputs it. And then it reads the clock time again, so basically gets the time of how long the determinant or the function takes to run. This would have been the implementation of the GPU, but I didn't really get that far. I didn't really get past the kernel part, to be completely honest. The actual function to find the determinant is basically the determinant long, because that way it's large enough value. If it's a 2x2 matrix as an input, it's just going to do this simple 2x2 matrix calculation, and otherwise it goes down this mess of for loops to find recursion value, to find values, and then does recursion at the bottom, and it should then have the value be n, and then it'll calculate this, and then spits it back out, and eventually you get the output as determinant. Let's actually check out the kernel, which is kind of just a mess, to be completely honest. It's more or less just a graveyard of like 3 attempts that didn't really get that far, but that's why it just doesn't really even make much sense, and most of the code isn't even in CUDA, because I just kind of tried to implement it, and the farther I went, the farther I realized like this probably isn't going to work, and if it works, it's going to be just a pain to even implement it. Let's actually run the program. Yeah, since we're just going to run it on the CPU, we can just run determinant calculator without the professor NV stuff. We're going to put in a 0, we'll put in a 5, and then we're going to pass it the matrix 5. Runtime is 0, 0, just because it took less than a millisecond to calculate. If we run a little bit larger program, like say I have another matrix that's 10 by 10, so we'll just do a 10 by 10 matrix and run that. So now it actually took some time. The numbers get really big, and that's mainly just because these aren't like specific matrices that are actually meaning something. These are just random numbers plugged into a matrix. And that's why you're going to end up with just like a random large number or like a negative number that doesn't really mean that much. And yeah, let's actually look at the results that that I got. So I don't have the results for the GPU. I have the results for the CPU. As you can see, basically everything less than a 9 by 9 matrix takes less than a millisecond to calculate. So I wasn't even able to calculate a time. And then at a 9, it takes like 2 milliseconds, and then like 13 for a 10 by 10, and then it starts to really grow. And by 13, it's a 221 second runtime. And obviously, I didn't run it longer than that because the next one's going to take like 2,000 seconds or something, and that's going to be like 30 minutes, and I don't really want to do that. Basically, anything over a 10 by 10 matrix, the runtime on the CPU starts to really get long. So the main problem I faced was just that I couldn't really figure out a good way to implement it, and honestly, the project was a bad idea. Linearizing like a determinant calculator is really bad just because it seems like it calculates the same thing, but it's each of the calculations is a little bit different. So it's really hard to linearize much of anything in it. And that's kind of why I just ended up failing in the end. I think the 3x3 matrix strategy is probably the best way to implement it. It's not like it's not doable, I just wasn't able to do it. Here's a contribution breakdown in case you're wondering. Uh, that's about all I have to say. In general, I kind of just picked a bad project and ended up paying for it. This is what I got, and hopefully it's enough for some points. Besides that, have a nice summer.